What's up guys, this is Felipe here. Today I'm going to share with you a few tips on how to choose from which side to start when proving trigonometric identities. If you're not told to start either from the left hand side or the right hand side, then we will have to decide by ourselves. It's always recommended to start from the more complex side of the identity, and in this video we're going to look at a few examples on how we can identify it using a simple framework. The framework consists on comparing three aspects of the expressions on both sides of the identity. The first one is the number of trig functions. Typically, we will start from the side of the identity that has more trigonometric functions than the other one. The second aspect is the number of compound trigonometric functions. With compound, I mean like tangent, cotangent, secant, and cosecant. Then we will look at a number of complex angles, meaning the sum angle, double angle, triple angles, and odd even identities. Now let's apply our framework with 10 examples and see how it can help us identify from which side to start. Our first example is cotangent x secant x equals cosecant x. So using our framework, we can see that we should start from the left hand side of the entity because it has more functions, more trigonometric functions than the right hand side, because we have a cotangent, a secant on the left and only a cosecant on the right. So we must start from the left hand side. Our next example, tangent x plus cotangent x equals secant x times cosecant x. Again, using the framework, the first step is to look at the number of trigonometric functions. Both sides has the same number of trigonometric functions, so this criteria doesn't work here. Then we proceed to look at the second criteria, which is the number of compound trigonometric functions. So in this case, we can see that the left hand side is more complex than the right one, because we know that a tangent equals sine of x divided by cosine of x, and cotangent equals cosine of x divided by sine of x on the left. And on the right we have 1 over cosine times 1 over sine. So we actually have more trigonometric functions on the left hand side, so we must start from the left. Next, secant squared plus cosecant squared equals 1 over sine squared cosine squared. Now, using our framework, the number of trigonometric functions on both sides is the same, and the next criteria is the number of compound. Then we have to start from the left, because secant is equal to 1 over cosine, 1 over cosine, and cosecant is 1 over sine. And we actually have here an addition of two fractions that we can easily combine into one fraction and then reach the right hand side. Next example, sine divided by secant x plus 1 plus sine of x divided by secant x minus 1 equals to cotangent of x. This one is pretty easy. We can see that the left hand side has 4 trigonometric functions and the right hand side has only one, so we must start from the left side. Next example, sine of x minus y divided by cosine of x times sine of y equals tangent of x cotangent of y minus 1. Okay, again, using the framework, we have on the left 3 functions, on the right 2 functions. Then if we look at the number of complex angles, we see, if we look at the number of complex angles, we can see that the left hand side has a sum angle. So in this case, it's recommended to start from the left, even though the right hand side has a tangent and a cotangent, because we can apply here an identity to simplify the sum angle, to break it into more simple angles, and then simplify and reach the right hand side. So in this case, we must start from the left. Next example, 1 plus cosine of x divided by sine of x equals sine of x divided by 1 minus cosine. Okay, using our framework, the number of trigonometric functions on both sides is the same. The number of compound trigonometric functions is also the same. There are none. The number of complex angles, there are no complex angles. So what do we do? In this case, there is no side. There's no more complex or more simple side. We can start from any of those. So we can pick anyone. And in both cases, we must apply the trig, which is multiplying by the conjugate of the numerator or the denominator. For example, if we start from the left, we must multiply by the conjugate of 1 plus cosine, which is 1 minus cosine divided by 1 minus cosine. And if we start from the right, we must multiply by the conjugate 1 plus cosine of x divided by 1 plus cosine of x. And that way we can reach either the right hand side or the left hand side. Next example, secant x plus tangent of x all squared equals 1 plus sine of x divided by 1 minus sine of x. In this case, we can see that the number of trigonometric functions on both sides is the same, is 2. The number of compound trigonometric functions on the left is more than the right, because we have here a 1 over cosine plus sine divided by cosine. So we must, it's recommended that we start here from the left. And we also have a binomial squared. So in this case, we must definitely start from the left, because we can see also that in the right we We have two signs and we don't have any binomial squared. Next example, cosine of minus x divided by 1 minus sine of minus x equals secant x minus tangent of x. In this example, the number of trigonometric functions on both sides is the same. The number of compound trigonometric functions, on the right we have 1 over cosine, and tangent is equal to sine divided by cosine. So we have two compound trigonometric functions on the right, 2, and we here have 0. But if we look at the number of complex angles, the left hand side has 2 complex angles. That is not cosine of x, but is cosine of minus x. It's an these kind of angles can be simplified using odd-even identities. So in this case, we must start from the left, even though the number of compound trigonometric functions is 0. We can start from the left using simplifying these angles and then multiplying by the conjugate of the denominator. Next example, 1 minus tangent of x divided by 1 plus tangent of x equals 1 minus sine of 2x divided by cosine of 2x. Guess from which side we have to start? Yes, from the right, because the number of trigonometric functions is the same. The number of compound trigonometric functions is 0. Is 0 here, and we have here 2, but we have two complex angles. Two complex angles, sine of 2x and cosine of 2x. So it is recommended I will start from the right hand side, because we can, the first step will be like split this fraction into 1 divided by cosine of 2x minus sine of 2x divided by cosine of 2x, and then 1 over cosine minus tangent of 2x. Now we have one tangent and 1 over cosine. This 1 over cosine can be expressed in terms of tangent using an identity, and this tangent of 2x can also be expressed into a tangent of x using also an identity, and therefore we can reach our answer. Next example, and the last one, sine of 2x equals 2 cotangent of x divided by cosecant squared. Now, can you guess from which side we have to start? Using our criteria, the number of trigonometric functions on the right is 2 and on the left is 1. So we must start from the right according to that criteria. The next one is number of compound trigonometric functions. Again, we have two. We have cotangent and cosecant, and on the left we have 0. So according to that criteria, we must also start from the right. Then we also have the number of complex angles. On the left we have 1, and on the right we have 0. But in this case, since the right side meets two criteria, I would say the right hand side is more is a better option to start. So I hope you enjoyed. Let me know in the comments if you have any questions, and I'll see you in the next one. Thanks. Bye.